Good day, students, and welcome to the last episode, I guess you could call it, of Unit 2 of our Equations, Expressions, and Inequalities unit. This particular skill is an 8th grade skill, I believe, and it is talking about how we solve equations when we have variables on both sides of the equation. How can we go about still trying to figure out what that variable is equivalent to? So we're taking a step back from inequalities and going back to equations. However, in this video, I do have an example of an inequality. So you could have variables on both sides of an equation, but you could also have variables on both sides of an inequality. And we've already talked about how we use the same properties of equality to solve those. So I actually have an example of an inequality in this video as well. So you can just see how it works. So the main thing that you need to know is when we are solving equations and there's variables on both sides, the properties of equality apply to the terms that have variables. So that's the first thing we're going to write. We're going to write the properties of equality, or we could just abbreviate it to our POS. The POS apply to variables as well. Okay, so we can use the addition property of equality, the subtraction property of equality. We can use that with our terms that have variables. So let's just dive in with an example. So we have the equation negative f plus 2 plus 4f is equivalent to 8 minus 3f. So the first thing we want to do when we solve equations is combine any like terms. Well, we have like terms on this side of the equation and on this side of the equation. So the first thing I would say is let's combine the like terms of negative f and 4f. So this is the same thing as negative 1f plus 4f. So negative 1 plus 4, negative 1 plus 4 is equivalent to 3. So what we're left with is 3f plus 2 is equivalent to 8 minus 3f. This is now our equation where we have combined our like terms. So the key when you are solving with variables on both sides is you want to make sure that you move the variable so it is on one side of the equation. And it doesn't matter if you choose the left-hand side or the right-hand side. It doesn't matter. You can do it either way and you still end up with the same answer. I always like to try to move the variable to the left-hand side of the equation because that's traditionally how we write our solution or our solution set. If it's an inequality, we always write it as x equals whatever or f equals whatever instead of the opposite, like 2 equals x. We typically don't write it in that format. So if I'm looking to do that, if I'm looking to try to move it to the left-hand side, what I'm going to do is I'm going to look at, I am subtracting 3f. So I can use the addition property of equality to add 3f to both sides of the equation. So if I add 3f, this is going to cancel out and we'll be left with 8. And if I add 3f over here, I'm just going to combine my like terms. So 3f plus 3f is going to be 6f plus 2 is equivalent to 8. And now, look, I just have a regular two-step equation. So I'm just going to, again, use my properties of equality. So since we're adding here, we're going to use the subtraction property of equality to solve and get 6f is equivalent to 8 minus 2 is 6. Then I'm going to use the division property of equality or depot. 6 divided by 6 is just going to be f. 6 divided by 6 is just going to be 1. So f is equivalent to 1. And if I went in and plugged in f on every single place that f is equivalent to in this equation, I would get the same thing on both sides of the equation. I would get two expressions that are equal to each other. If I went and plugged in f right here, 6 times 1 plus 2, 6 times 1 is 6, plus 2 is 8. 8 is equal to 8. Boom, I know I did it correctly. So all we did was take the POS and apply it to the terms with the variable, and we just combined our like terms in the midst of solving an equation. Let's do kind of the same process, but now we have an inequality. So it's a little bit harder. Remember I talked about after we learned about the inequality flips, the first thing you want to do is ask yourself, am I going to need to flip the inequality symbol? Well, neither of my coefficients is negative, but since we're going to have to combine them, that could mean that maybe one of them is going to be a negative. It just depends on what we have to, add or subtract. So we can make that determination a little bit later in the problem. So the first thing I want to do is, again, try to move the variable to one side of the equation. I prefer moving it to the left side. So that means I'm going to take 7e and I'm going to move it over here and combine it with the 9e. So since it's a positive 7e, I'm going to use the subtraction property of equality and subtract 7e from both sides of the equation. And you'll notice I didn't mention it before, but I'm lining it up with its like term, right? So 7e and then over here with e. So I'm using the subtraction property of equality. So 7e minus 7e is just going to be equivalent to negative 11, that minus 11 that is left. 9e minus 7e is 2e. 9 minus 7 is 2. And then we're going to keep, there we go, it's focused. We're going to keep that minus 7 here. So now we have the inequality 2e minus 7 is greater than negative 11. And now this looks like just a regular two-step inequality. So I'm going to use the addition property of equality to get rid of the 7, my APO property. So I'm left with 2e is going to be greater than negative 11 plus 7 is going to be negative 4. Negative 11 and we go up 7 spots on the number line means negative 4. And now we can take a moment to look. My coefficient is positive, so I'm not going to have to flip the sign. The sign's going to stay greater than. So in order to figure out the solution set for e, or all the values of e that make this statement true, I'm going to use the division property of equality, since there's multiplication going on over here with 2e. And I'm left with e is greater than negative 4 divided by 2 is going to be negative 2. So e can be any number. It just has to be greater than negative 2. So it could be negative 1, 0, 1, 2, 3, 3.7, 4.2, etc. And if I went back and plugged in a number that is greater than negative 2 to e, I would end up getting a statement that is true. I would get something that's greater than over here compared to what's over there. So again, all we're doing is using the properties of equality, but it's kind of like we're combining like terms through the property of equality as we solve. For your practice questions today, there are just 2 problems I would like for you to try. Here are the 2 problems. So you can take a moment and pause and copy them down. All right, the problems I would like for you to solve are 4b, that's the letter B, plus 5 is equivalent to 1 plus 5b. Number 2 is negative 7 plus 4m plus 10 is less than 15 minus 2m. So again, don't forget, as you kind of start to solve, see if your coefficient ends up being negative once you kind of combined your like terms. And don't forget, if it is negative, you're going to have to flip that sign. If y'all have any questions, please make sure to ask your teacher. You may check your answers to these 2 practice questions in your table of contents. And I hope you have a spectacular, that's the adjective I'm going to use, spectacular day. Bye.